Well, a very good evening, everyone. I hope that you can hear me, and thank you for joining us here for the 4th Sheffield IoT Meetup. This is the first webinar and is a new experience for us, and it's fair to say it's experimental. So I ask you to bear with us if we hit any technical issues. A quick introduction to myself. My name is Mark Davies, and I'm co-founder of Ioetec. We're based here in Sheffield, and we specialise in IoT data security. We set up Sheffield's IoT Meetup to build an IoT ecosystem that will enable individuals, interested parties, and organisations to share their capability and stimulate conversations and collaboration. We hope to bring together parties to enable real-world IoT applications to happen through facilitating technology, R&D, and commercial partnerships. We'd like to help position Sheffield and Sheffield Digital as a leading IoT centre and to lay the groundwork for larger events and activities to reinforce this reputation. Now, this evening wouldn't have been possible if it had just been left to me. We have a brilliant sponsor in pitching. University of Sheffield's project focused on addressing the barriers to IoT adoption across manufacturing, health, the energy sector, smart cities. And as part of this, Sheffield is collaborating with multiple industry partners and researchers in Oxford, Cambridge, and Newcastle universities. And we're also supported by Smart Sheffield, Things Network Sheffield, and the IoT Security Foundation. Now, I need to make a specific shout out and express my deepest gratitude and thanks to Rosie, Fern, and Kerry from the pitching team who have helped organise and promote this event today and for setting up the online platform so you can all join us this evening. Now, a little about the way we plan on this working this evening. I'll be introducing our speakers throughout the course of the event. And after each session, I'll be posing all of you one of our questions. I'll be posing any of the questions that you may have. So can I ask you to post them on the chat facility where I'll record them and address them to each speaker as they finish their presentation. You'll find the chat facility in the bottom right-hand corner. There's an arrow button that will open up the chat facility, and I'll record those. And as I say, I'll pose your questions to each of the presenters. And also at the end of each session, we'll be running a poll. This is a facility that you can get on these webinars, and we're going to take advantage of this. We'll be asking some basic questions about how to for us to act upon and hopefully improve future events. And also at the end of each the meetup, we traditionally have a shout out session. So for those wanting to broadcast any news, activities, announcements you may have. So again, use that chat facility and let us know that you'd like to contribute. We'll try and get your audio in or just key in your content at any stage, and I'll mention it during that session. So to quickly outline the programme for the next hour or so, we have a great lineup of industry experts this evening. To start off, we'll be starting with Navid Quraishi, who's the Senior Manager of Business Development at R2 Data Labs, Rolls-Royce. He'll be talking about the IoT and intelligent tech in Rolls-Royce engine health monitoring networks. He'll be followed by Ibrahim, who's the co-founder of Northern Crucible. We'll be going through that information about Northern Crucible, introduce who they are and the needs of traditional industry. Gavin Hill, he's the project manager at the University of Sheffield Advanced Manufacturing Research Centre, the AMRC, and he'll give you a whistle-stop tour of the industrial IoT at the AMRC. Mike Fulks, CTO and co-founder of Ioetec, my co-founder, and he'll be talking about protecting the uptake of Industry 4. And Alex Kelly, last but by no means least, and stay with us for the entire duration of this programme. He's the head of IT at Tinsley Bridge, and he'll be talking about exploring IT's potential in Sheffield-based SME manufacturers. So that's the lineup we have. If you enjoy the evening, I'm going to pass you over now to Navid from R2 Data Labs. So hopefully that's to be.
It's Kerry. Navid's just lost his mic option, so it might want to go on, and I'll get it sorted out.
Okay, thank you, Kerry. All right, so that's the first of our technical issues. So we're going to hand you over, maybe straight over to Sean at Northern Crucible. Sean, can you hook in with us now?
Yes, hope you can hear me and see me. Yes. Hello?
Yeah, that's great, Sean. We can both hear and see you. Thank you.
Okay, I'm going to share my presentation and we'll get going. Okay, can you see this?
Yes.
Yeah, okay. Okay, all right. Well, I'm Sean Ibrahim from Northern Crucible, and I'll do the introduction in a minute, but really the topic for me is bringing smart technology to all factories. Most of the people I know are in legacy industry, and I'll talk about that in a minute. Let me just move on to my next. Okay, so Northern Crucible, we're based in Sheffield. We look after the local region. It's a voluntary forum for manufacturers in our region. It has a membership of about 200 manufacturing companies, mostly small to medium enterprises. And it's all voluntary. There's no charges for anything. All the information we give is free. All our speakers do what they do for free. So it's a great place for sharing information. And if you look down there, there's some of the topics that we cover in our monthly sort of meetings, import, export, skills gaps, so on and so on. So we do cover the range, but today I'm going to obviously focus on IoT for you. So I'll give you a little bit of background about myself. I've spent 30 years in the industry. When I say industry, that's manufacturing industry, in MRO supply and smart tooling. I've been involved in lean and more recently apprenticeships. And I've got a background in pneumatics as well. And I put this in because it's quite interesting. 25 years voluntary work at sport at high levels. And why would I put that in? Well, probably the biggest thing that I've seen in my 25 years is the giant leaps forward that British sport have made. And I've watched elite athletes pick up gold medals. And when I was a youngster, we were lucky if we picked up 4. And it occurred to me that why doesn't our industry adopt the same attitude? This is why I'm talking to you and why I get excited about it. I have close links with Sheffield University. So I'm on the board of the NUS there, and I'm obviously involved with a lot of the graduate programs there, and Sala, who were great friends of mine. I work with various levels with 340 regional firms. So obviously don't work deeply with them, but at various levels, generally with leadership of some sort. And I'm a proactive supporter of industry in our region. So the real topic that I wanted to go on about was Industry 4.0 and the challenges with the uptake from legacy industry. Legacy industry, for the terms of this talk, is small to medium enterprises. They are generally the metals industry around our region. They could be any industry. To be fair, any industry that needs to change. What are the obstacles? Well, the obvious ones are a lack of any or all of the following: money, knowledge, and talent. Money is obvious. Knowledge is really they don't know what's available, and equally, if they did know what was available, they don't quite have the talent or the skills to implement it. There's also a poor risk management. They don't quite understand, or for instance, we're in the middle of a coronavirus crisis, and nobody could have predicted that. However, with Brexit coming into play, people should have been planning for a big downturn in trade and how would they cope with it. So, but they tend not to look that far into the future. That's what I've found with local industry. The age of any or all the following: equipment and workforce. The equipment is very, very old in SMEs in and around the South Yorkshire region, typically 40, 50 years old. That's not surprising. And the workforce, average age of the workforce in industry, certainly touching 50 at least. So there's a time bomb waiting to go off. There's a skills gap, and unfortunately, it's not going to be filled quickly. So we have to do something else. There's an unwillingness to disrupt work or run pilots. So basically, it means that they're not very willing to stop production to try something new. And that's a difficult thing for people with new technology to break down the door. They have disconnected departments and poor change culture. Disconnected departments, what I mean by that is there's a lack of communication between departments. It's a paperwork-driven industry still, even today. And yes, they do have computers, and however, the computers only do accounts, or the computers will only churn out orders or do CAD drawings. It's not connected. And then they have a clumsy digital architecture. It's bolted together, and I've been in lots of places where we couldn't put smart technology in because the systems couldn't be changed because they didn't want to upgrade their systems. They were terrified if they upgraded, the systems would crash. So my advice to these people were to learn as much as you can. Who would you learn from? Industry experts, from financial organizations. There is plenty of financial support to take up new technology. People are really not aware of it or don't know how to apply for it. There's plenty of support in further and higher education. I offer it. I offer business improvement technique where I train their staff. It's offered at university with projects. There are plenty of organizations that will work with them. And of course, there's Google. Google, the whole answer to everything is probably on Google somewhere. And then the best of the lot is go and see and talk to other manufacturers. And obviously you can learn. So I encourage that a lot. So if they're going to engage with a supplier, these are the things that I encourage them to do. Obviously, work out what their budget is, understand who their stakeholders are inside the company, who's going to lead the project, who's going to use the equipment, where does it trickle down to. Make sure everybody's involved. If you give everybody some ownership, you'll get better results. Time frame, understand your time frames. Define the project, the assets, what equipment do you want to monitor, and how will you use the data variables, what information do you want to collect about your equipment, performance, what is the sensing range of your data sampling, how often do you plan to review your data, connectivity, power, obviously simple things like power supply, is the equipment there, is the power source there, and the environment. Is your equipment indoors or outdoors? Environment can impact obviously on connectivity. If in many factories there's lots of steel which interferes with connectivity. So a lot of these things come into play. So once you've engaged with your supplier, these are the things. Now, what I say to people is make this checklist up and engage with at least 2 suppliers, similar suppliers, and then you can get a comparison. So some very, very obvious questions. What sets you apart from others? Do you offer training, updates, etc.? What is it? What is your what's the differentiator? Can you demonstrate on site with existing processes? That makes sense, yeah, obviously. Can you supply references on a similar project in the industry that we're in? That would be a great one. Use somebody with experience. What types of IoT data analyticals are available? How customizable are my IoT dashboards? Obviously, people want to read data in different ways, and not always the way that maybe they would be created. How does the IoT data collection work? You need to know that. How does IoT platform monitor and control connected devices? Again, it's all basic things. Now, for somebody who has no knowledge, if they do some Google research and work with other manufacturers, use these questions, they will start to build up a massive wealth of knowledge on their particular subject. Again, how does the platform handle IoT security? What IoT protocols is the platform compatible with? What IoT devices can be controlled? Cloud storage, what options are available? IoT will ask IoT vendors about licensing. Important to know because it's a cost. How frequent are the updates and are they included? Request a clear quote and time frame. Defined so you can compare. When I say defined, I mean broken down clearly so you can compare each bit along the way. So really, if you have these things and follow these simple rules, this is a low-tech presentation, just follow these simple rules, you will get to where you want to be. The other thing that I would say is IoT suppliers need to understand all these rules as well. With legacy companies, there's a mistrust of IoT providers, really because they talk a different language, because they're a different age, people feel uncomfortable. You need to get over these hurdles. Ideally, you need to understand what makes them tick, and remember your selling time to talk to these people is only really as long as a cup of coffee will last. That's your time. You've got to convince this person that you're the right one for them in that time. So I'm hoping there's a little bit of an insight, very, very low tech, but a little bit of insight into my world. I offer lots of advice to companies, and I'm happy to help anybody. I'm not an expert, but I will put you in touch with the right people, the right experts. If you want introductions, I will do my best. Thank you very much.
That's great. Thanks very much, Sean. Thanks for that and an insight into the association that you've set up with Northern Crucible. I guess one of the natural questions would be, and you've touched on it in your presentation, is how do we build, first of all, how do we build the bridge between the traditional industries who are stuck in a very traditional mindset to those people who are, as you say, in a different age group, different technology, different mindset? How do we bridge that gap? And one of the things I was going to ask you was, how do we bridge that trust element? How do we create the trust element between those industries and the digital industries? How can we do that? What's your thoughts on that?
Well, the first thing is obviously recommendations, but if you haven't got recommendations, free trials, let people try the thing out. You've got to get a reputation, therefore you've got to work with somebody. So you've got to be willing to give up your time and make this project work, get the item into them, even if it's a case of, you know, a reduced price, whatever it is, but work with them. Build yourself a reputation. The best business comes word of mouth. I will give you another company, United Caspar in Chesterfield. The people who put the IoT into that were really clever. They did it all for free and let somebody else pay for it. They did an energy saving project, and they cut down Caspar's energy consumption by, I think it was around 700,000 per annum. However, they made a fortune selling a lot of the power they saved back to the grid. So they made their money selling the power back to the grid. Now, United Caspar bought into it totally because it was an experiment. It didn't cost them, and it potentially was going to save them. And they get references, they get introduced all over the place. And the best introduction of all is the MD. The MD sells the product for them. He's trustable, and he's doing it because he's saying, "I save money."
Okay, thanks for that. Thanks, Sean. There's a number of questions that have come up on the chat there, so if I can pose a couple to you, if that's okay. Great. Some of them are based around the skills gaps that you mentioned earlier on. Between, well, the traditional industries don't tend to have these in-house. What do you think, would you say the skills would be in the greatest demand for these more traditional operators?
Analysts, that's the new frontier. People don't understand it. It's a need. People are getting data, but they don't know how to use the data, and they don't know how to what to do with it. For example, I used to do lots of bolt tightening, and if you could read the data, you could tell when somebody had dipped a bolt in oil because it would go in too fast. It would give a spike, and if you can learn to read that data, you could actually go to the operator and tell them, "I know what you did. Don't do it again, please," or retrain them or whatever. But it's understanding data, and people at this moment in manufacturing haven't got their head around that. They just have not quite got it around. So that's a massive gap. The other thing that is missing in large companies, people of my age, they're touching 60 thereabouts, and the IT people in there are not that far off in age, and they are missing. Even though they know the subject, a lot of this new technology is lost. So, sure. Really, you need to not upset them, but you need to sort of teach them and let it be their idea. Let them introduce it to the director.
Sure, I get that. You mentioned costs earlier. Is always all companies are concerned about the way that they control their costs. There's potentially grants in this area, particularly in traditional areas and with sort of support investment. How do you connect with the sort of things like Growth Hub, for instance, in Sheffield? How does that work? Are your memberships aware of that type of investment that's available to them to reinvest in their businesses?
I share links on it, and I do tell them really what we need to be doing though is inviting these experts in. We're still new. We're still under a year old, and there's more meetings to have. This could be a great thing for online. It could be a perfect thing for online.
Yeah, so, great. Well, we're hoping to run some workshops with the universities later on in the year when we can start socializing again, and so hopefully there'll be an opportunity there. It seems quite an obvious one to try and put these together. Okay, Sean, thanks ever so much for your time. I'm mindful of that we're trying to sort of keep to a fairly tight timescale here, so if we can get you to answer any more questions online that are coming up, that would be great.
Okay, thank you. Goodbye.
Cheers, thanks very much. Thanks to Sean for that. I'd like to introduce you now, if I may, to Navid Quraishi, who's the Business Development Senior Manager at the R2 Data Labs at Rolls-Royce. So, Navid, if I hand over to you now. Thank you.
Thank you very much. Just to share, my slides are hanging, so can I please request somebody else to navigate the slides? That's very kind of you. All right, so good afternoon, everyone. So I work at Rolls-Royce, and Rolls-Royce is a manufacturing organization. We like to identify ourselves as a technology company. Next slide, please. So what holds very true in our heart is we focus on pioneering the power that matters. And we do that through a number of ways. We are very, very focused on championing electrification. An example of that is through our eFan-X program, where the program is committed to meet the EU technical environment goals of the European Commission's flight path. That's their 2050 vision for aviation, where we're looking to reduce CO2 by 75% and the NOx emissions by 90% and the noise reduction by 65%. We're very passionate about reinventing the digital, and I will be touching on that later on. Everything we do is about operational efficiency, and so continuously we look at how can we transform the days of our lives, everything that we do inside and out throughout the globe within our business. And for a lot of the activities that we do, for the products that we put in the market, they tend to be highly intensive utility assets. And so we often look at how can we better enhance the circular economy for everything that we do within our operations. And so vitalizing our existing capabilities is again very important for us. Next slide, please. Thank you. So our low carbon approach is through developing products and products that are indeed smart. So the topic of today's conversation is IoT, and we use a lot of sensors throughout our engines, our assets, to be able to detect anything above 7,000 parameters. And so that enables us, Sean was touching upon it earlier on, for us to measure the most minute of things to the most detailed of levels. So for example, we can sample data all the way through to the 1 Hertz data rate, which is like for every second we can capture data for all the parameters that we monitor, and we're able to always trend on alerts and highlight any issues that are coming up back to the airlines and to the ground operators that use our assets. Our approach towards technology is again focused on ensuring that we continue to champion our low carbon focus, and so we're always focused on how can we make our assets lighter, how can we make the noise lower, how can we make everything operate cleaner. And indeed for operations where we manufacture our assets and where we conduct our business, we make sure that we're continuously investing in our green gas house emissions and lowering that. And our intent is to go zero by 2030. Next slide, please. So Rolls-Royce has 3 main business units within it: civil aerospace, defense, and power systems. If you could go to the next slide. And so in the civil aerospace business, which is the topic of today's conversation, my focus, we have 2 main areas within that business sector. One is where we produce engines for large wide-body aircraft, and one is where we produce engines for our business aviation aircraft. And so some interests I'd like to share with everyone on this call today is we are racking up over 16 million hours a year on the Trent family, which is for our large engines. That's equivalent to over 16,000 trips to the moon and back. The Trent XWB fan set, which is again part of our large engines, is almost 10 feet across, and it can suck up to 1.25 tons of air every second at takeoff. You know, we expect these engines to fly for over 20,000 hours before its first overhaul. This is equivalent to over 11 million miles flown, or 450 times around the world. At takeoff, each Trent high pressure blade produces over 800 horsepower. That's equivalent to an F1 engine, and there's 66 of these blades on each Trent 1000, and there's 68 of these blades on each Trent XWB. Could you go slide, please? Fantastic. So, IoT, where are we today? So today, digital allows us to do things we could only dream of when we were introducing Total Care, which was quite a few years ago. Now, Total Care is our mechanism for putting long-term service contracts in place with airlines that where we guarantee a number of flying hours for every dollar that they pay for having our engines with them. Today's Trent engines mark a big step forward from the early on days when we introduced the RV211s. So as those three circles you see over there, that's product, service, and digital, started to overlap, we were able to bring in new capabilities like intelligent EHM and enhanced efficiency management that provide improved value for our customers. So what's EHM about then? Actually, could you go to the next slide, please? Sorry. Thank you. So our focus is to ensure that our engines are always connected, right? So I touched upon earlier on that we've got plenty of sensors on these engines, measuring vibrations, pressures, temperatures, noise. And so it is very important for us that these engines are not only connected to the airplane and the operators and the people using them, but also connected to each other, so that we understand how the health and the behavior of one engine is that we manufacture compared to another engine and another engine, so that they understand each other's DNAs, and we can always plan for how best to further enhance their capabilities moving forward in different environmental conditions. And that takes me on to, we need our assets to be contextually aware. And that is aware of their operating environment, aware of the fact that, they're about to go into a very cold temperatures, they're about to go into a sandstorm, they're about to go into high temperature environments. And so what are the corrective measures these engines need to take as a result of that to ensure that we fly you and myself safely? And then we need our engines to comprehend, so make decisions on the back of the information that is being supplied into them. And we have to do this at a very, very grand scale. So one way to do that, next slide please. One way we do that is through the provision of equipment health management. And so equipment health management is all about avoiding surprises, keeping the fleet flying reliably so that our passengers are happy. For almost 3 decades, we've been using the power of data to give our customers greater control of their assets and insight into their operations. We have close to 30 years of experience in data integration and analytics. In the aerospace sector today, 1,300 customers relying on our data service monitor 13,000 engines, and that is 6,000 to 8,000 commercial flights per day, and analyze billions of data points on board per flight. On the Trent service alone, we monitor 14 million miles flown every day, and that's approximately 4,500 engines. That's over 5 million parameters per day, average process time 3 minutes. That's what we aim for. That's 384 roughly odd observations that we manage per day. That's 3.9 minutes average operations on arrival rate. So to put that all in context, the engines are flying, they're transmitting the data through the aircraft, depending on what the airline spends, and they can afford. Either it goes live into a satellite link and comes into our operations, or as the airplane lands, the data is transmitted to their ground station and comes back to us. And we put a lot of automation in place to make sure that we can continuously analyze all this information and play it back to our operators. 50% of our team is always focused on new efficiency and capability programs to continuously evolve this capability. Next slide, please. So what is EHM really all about? So we sense, we acquire, we transfer, we analyze, and we act on the data. And in a nutshell, that's where the value is for our customer. I'd like to talk about the process now for a moment. If you go to the next slide, please. So I touched upon earlier, that the engines captured the data, but there's also the wider aspect. The aircrafts capture the data as well. Depending on what the airlines is prepared to spend, these data points get either transferred live as they're flying towards a satellite, and then we get them, or when they land and we put them onto the ground station, and that gets transmitted. And this is for all the airlines in the world who fly a Rolls-Royce engine. Once that data comes into our systems, we apply data analysis and trend monitoring on top of it. Now, where there is a high red alert type issue that needs immediate attention, the airline, the ground crew, the pilot, our field service representatives, they're all made aware automatically through our systems. And actions are taken to ensure that there's minimal aircraft on ground time so that your flights can take place as soon as possible, as safely as possible. Through this data also, what we do is we also use it to help us understand when do we need to remove our engines for maintenance. See, for airlines, time is extremely precious, and for you, your safety is extremely precious, both for the airlines and for us, for everyone in the aviation industry. And so being able to plan intervals for when we need to take these assets off and being able to bring it to our maintenance repair overhaul shop bays across the world, we need to be able to use data to be able to do that. Next slide, please. And so this is where, our intelligent care comes into play, where we have services and capabilities in place that enable the airlines to understand when do they need to plan overhauls. They help us understand how much of work do we need to do on the engines. They help the supply chain coming into us understand how many parts do we need, where do we need them, when do we need them. And so this is all enabled through IoT, being able to capture all of this information at all of these places in the maintenance, repair, and overhaul shops, on the aircraft, in the engine, on the operations, making sure that we use smart capabilities such as, you've seen these days the emergence of augmented reality as an example. So making sure the field service representatives, when they're doing their work, they're given the right information in the right time, on the right way, so that they can carry out all the activities that they need to ensure that the flight takes place as soon as possible. Next slide, please. And so this is where it becomes very important for us to always create virtual representations of the physical assets that are out there. We call this the digital twins. And where through creating these digital twins, these models, these virtual mimicries of the real life asset that we have, we compare the actual performance of the assets. We compare the actual performance of these assets to the simulated behavior we modeled earlier on. What are the differences that we're noticing? Why are those differences there? And what we do then is we use machine learning, we use analytics and AI to make sure that we constantly learn all of these things, putting it back into the system, make sure that sorry, there was some feedback there. And then we always ensure that we're using everything that we have learned thus far through machine learning, through AI, that we can continuously predict and optimize the future of the physical outcomes that we're seeking. And alerting is very core to everything, so that we make sure that everyone has the right information at the right time to take the right corrective actions. Next slide, please. And so the future for us is where we're looking to develop cyber physical services with a digital mindset first, with the digital approach first, always thinking about how can we make our products, our services for everyone, for our customers, for yourself, smarter. And this is always enabled through capabilities such as AI, machine learning, IoT, cybersecurity, so that we don't get hacked all over the place. And indeed, the people who make this possible are the young talents such as those on this call today. Next slide, please. Thank you. I'm not sure if I've overrun. Hopefully I haven't. But I am good for taking questions now.
That's great, Navid. Thank you so much for that. Really interesting, particularly from my perspective. I had 40 years in commercial aviation and was very reliant on Rolls-Royce's technology working every time I went to work. So appreciate that. A couple of questions, if I can, Navid. One of the questions from Harry says, "What is the turnaround time to incorporate new technology into aircraft engines? And what's the does this fit in with the emissions reduction targets?"
Okay, so that's it depends what type of technology we're talking about. So is it the technology that you're looking to fit a new type of sensor within an engine? And indeed, then that would require you to take it through a certification process to ensure that the integrity of the asset is not compromised. Now, for something like that, it take a bit longer. So typically, you would, depending on what you're trying to do, it could be anything above a year plus to try and take that through, because it has to go through all of the testings again. To gain the certification, and there's a lot of fun tests we do to our engines. If anyone's interested, please go onto YouTube and check out things like bird testing engines and blade off tests, explosives on the fan blades of our engines, to ensure that when something does go horribly wrong, everything is contained within the cage of the engine itself, and there is no risk to it.
Yeah, I do remember being in the industry of them firing chickens at turbines while they're being turned. Good way of making minced chicken, I guess. Thanks for that. One other question then, and a little bit more topical, is about we're seeing the Formula One industry turning re-engineering some of their expertise. I know they're in a fallow period at the moment. I think so is the the avionic industry as well, to a degree. What is Rolls-Royce doing at the moment as far as tackling the COVID-19 and its impact? What engineering is going on? Presumably Rolls-Royce are doing something like that. I hope I'm not setting you up like that, but that's a good question.
It's a fantastic question. Over the coming weeks, I'm sure that the public will hear more about what Rolls-Royce is doing with regards to COVID-19. But indeed, ensuring, so what is our main priority? Our main priority is to focus on continuously ensuring the integrity of the industry in its entirety. Rolls-Royce is not just about civil aerospace. We also have a defense sector, and we also have a power system sector. And in the defense sector, we very much, our customers are the UK Ministry of Defense, and indeed the US Department and so on. And in power systems, our assets are used on rails, on trains, sorry, and indeed to continuously power big yellow trucks we see digging sand off at mining places. And so we're a very diverse group. In terms of our response to COVID-19, we are putting a lot of effort in ensuring that we're coordinating in the aerospace sector with the airline to plan appropriately as to when can we effectively adjust our plans for the maintenance, repair, and overhaul activities that they need once their assets start flying again. We work with the governments indeed in that space as well, and so that's the civil aerospace sector. And the power systems sector, life has to keep going. Trains have to keep running, and so we're making sure that safely we're continuously being able to provide the necessary services into those industries to enable them to operate. And defense, if we look at the fact that the military is being pulled in to provide cargo services, to take medications, ventilators around the world and everything else, we have to make sure that our assets again are powering the assets that they're using to effectively transport everything. So to a very large extent, because of the diversity of our organization, we're still very busy.
Yeah, I'm sure you are. I'm sure you are. Thanks ever so much, Navid. Any questions that come up on the chat, if I could ask you to just quickly scan those and answer the ones that have come through, that would be brilliant.
Absolutely.
Thanks ever so much for an interesting presentation. Appreciate it.
My pleasure. Thank you.
Thank you. Okay, we're going to try our first poll now, which I'm hoping, Rosie, that, here we go. It's straight up on the screens now in front of you. If you can just take a couple of moments just to give us an indication of how you heard about the Sheffield IoT Meetup. Just give us an indication of which are the best methods of us trying to contact you and reach out to other people. That's fantastic. A couple more moments. That's great. Thank you all. So that looks like the result of that is through word of mouth. So the networking is certainly happening, which is great, and also secondary through Twitter and through LinkedIn. So I'm glad some of the promotion that Rosie and her team have been doing. So that's fantastic. Okay, so let's move on to our next speaker. We've got Gavin Hill now, who's the project manager at the University of Sheffield's Advanced Manufacturing Research Centre, the AMRC, and he'll be talking about the IoT, a whistle-stop tour of the industrial IoT at the AMRC. So, Gavin, are you there, sir?
Yes, I am. Can you hear me okay?
Yeah, hi, Gavin. Go right ahead. Welcome.
Awesome. Okay, folks. So I'm going to try and make this pretty, just pretty relatable. I think we've had some great chat from Sean to kind of introduce us into a lot of stuff that honestly we see on a daily basis, and we also get heavily involved in a lot of the stuff that Navid has brought in as well. But that makes what we do quite expansive. But I just want to today focus on some stuff that's a little bit more relatable, or at least that's the hope and aim. So I'm going to just quickly talk through some practical examples of some projects that we've worked on that are IoT related, and most of that focusing on IoT devices or on edge devices or gateways. So the first one up, and I apologize, the formatting of my slides doesn't appear to have liked it to move over to this collaborate session, so some of the formatting might be a little bit off, but I'll hope that the message still gets through. So one of the things that we see a lot of, and I think people can probably resonate with, is that there's a lot of options out there for IoT and Industry 4, and there's not necessarily a hell of a lot of information about what's best in a certain scenario or what's best in general. So we took on a project about a little over a year ago where we looked at edge devices or gateway devices. So gateway devices allowing you to take data from the shop floor and then transfer it to a database or the cloud or somewhere where it could sit at rest. Or an edge device, basically very similar, but just a computing device that sits as close to the manufacturing floor, as close to the sensor, the machine that it's connected to as possible. And there's kind of two areas or two different thoughts or groups of technology in there. You've got the industrialized stuff, that's stuff that you get from someone like, say, National Instruments or Dell or Siemens, and those pieces of kit are fairly expensive, but they're CE marked. They've got an awful lot of just industrialization side behind them. And then the second type that we tend to see are stuff that's come from the maker world. So you've got things like Arduino, Raspberry Pi, BeagleBone, these sort of tech. There wasn't really anything at the time that we could find that was able to show people what was the difference between them, when should you use what. So we set up this system to get just a range of those sort of devices, and to check out and make them do the same sort of task that you would expect them to do on the shop floor, and be able to then compare and contrast them, and then be able to give people a bit of guidance when they come through the door or when they give us a bell on, for their use case, what's the right solution, or at least the general right solution. So each one of these devices is doing some digital input output, it's doing some stepper motor control, it's doing some analog input and output, it's transferring data over a protocol called MQTT. And we had that running, and still have it running constantly for about 12-14 months now at this stage. And we're getting data constantly on that, on how often they fall over, how robust they are, what the data integrity is like. And that allows us to talk to people such as yourselves and just give a little bit of guidance. And it really kind of allows us to do a bit of an apples for apples compare. Now, most of what I'm going to talk about from here is a lot of projects that involve things like these devices in examples, but hopefully it will give you a fairly broad range of what can be classed as IoT. So this next one up is in the construction sector, and it really kind of might change or challenge people's ideas of what IoT is, or industrial IoT. This is a system for construction. So effectively it's a projector. It's a smart projector that projects onto the wall or onto a surface on a construction site. And that allows someone like a plumber or an electrician to be able to do the first or second fix of their job really quite quickly and easily. Whereas previously, they are in like a normal situation, they would have to look at drawings and then be able to measure up where they need to put things in. This system does that for them automatically, and there's not an awful lot of smart stuff in there until you get to thinking about some advantages here. So the first thing is that is a smart projector. So if we need to move it from one side of the room to the other, it will recognize that it's moved and recalibrate itself to put the instructions back in the wall in the right place. And the next piece is that can be a connected system as well. So let's say you're driving to work and you've got that in the back of the van, and you've got one set of instructions or drawings on the way there, and during the journey, the architect or the building services engineer makes some amendments to that drawing for whatever reason. I know they shouldn't, but let's say they have. As long as that can be connected to the internet at some point during that journey, or when you're getting it set up, you can automatically get those latest version of those drawings put there straight away, and that basically turns that whole system into an IoT device. Just a bit of a different application. Here again is another one that's a little bit different. So this is where we're looking at electrical cabs here. Yeah, again, the formatting's gone a little bit weird in the slide, but effectively an electrical cab where normally you want to be able to test that system before it goes out. So you get a digital multimeter, you put the probes onto the appropriate terminals, and you record your value. That involves, again, looking at a lot of paper and a lot of manual intervention. What we did, we took that premise and we added some IoT elements to it. So what we've got here is we've used an AR device, so we're using a HoloLens device in this case, allowing us to visualize where we need to probe without having to look at our paper-based instructions. So in the right-hand image, you can see that we've highlighted two of the blocks of terminals in blue and red, and then we can go and probe those. Now, the real IoT device here is actually the digital multimeter you can see on the right-hand side of both of the images. That device is Bluetooth enabled. And as a result, as soon as I make a connection using the probes, I immediately see on either the tablet or the HoloLens device, I see the value that I'm recording on the multimeter. And I can also then do something like just say record, and it will automatically record that value. So we don't have to worry about things like manual error or data entry duplication or anything like that. Again, just using an IoT device to enable a process and to significantly speed up the testing of these electrical cabs. If we scale that up a bit, we start looking at systems where we might have more connected devices involved and how they might fit into the full system. So this is a smart kitting shelf, or a pick by light system. And in the top right there, you can see my colleague Alex has basically he's went to a console. He's been told, right, you need to pick this part. And when he's told to pick that part, the LEDs underneath the part of the shelf light up green, and he knows where to go to pick up that part. He then moves on to the next component, and that one will be lit up for him next. Now, that system in itself is an IoT enabled smart kitting shelf or pick by light system. And I talk about that one for a couple of reasons. One of them is that it looks massively expensive, it looks very fancy, but after you take away the cost of the shelves themselves, that system's only about $3,000 in hardware. So it's not ridiculously expensive, it just looks like it is. But this system is then connected up to the MES system that you might be running, so the manufacturing execution system. And there's an awful lot of other IoT devices that are connected here as well. So if you look at the left-hand image, you'll see above Alex's head, there's a little black device there, and that's a LiDAR scanner. And what that enables here is that if you put your hand into the shelves at a point where you're not supposed to, so let's say the LEDs have lit up the top left sector, you just put your hand into the top right, it will flash red and it'll let you know you've went in the wrong place. And then it will also allow you to do things like automatically move on to the next step after you've picked the right component. It can register that and then light up the next box that you need to take on. And there's some other bits and pieces in here as well. We also use Raspberry Pi enabled cameras to identify what components we specified to be in what part of the shelves. And there's a lot more kind of smart stuff that goes on behind that, but with the interest of time, I'll move on to the next one. But this is just showing how you can connect up an awful lot of devices in an IoT sort of situation. And the advancement of that, or where you would see the development or use case of that, is in something like this, which is a smart workbench that we worked on with one of our aerospace and defence customers. And here you can see those kitting shelves again, so the pick by light systems in a smaller version are there, but you've also got projectors that are projecting down, giving instructions to the operator on the next part of an assembly, which are connected up to the MES system. You have camera systems that are verifying that things have been done and that the next process has occurred. And yet again, in aerospace or a sector like that, that's really important to have that verification. We've got smart tools on the bench there as well, which goes back a little bit to what Sean spoke about earlier on the likes of a nut tightening operation. Can you confirm via the data that you've got the right torque on a certain nut or bolt? And those smart tools allow us to do that because they're connected. They can transfer that information back up to the MES or to a central database where we can confirm if we've done the operation correctly or not. And we can automatically set the torque on the devices as well. But that's where you start seeing that bigger connection of an awful lot of bits and pieces. Now, the last one that I want to talk about, and I appreciate I am talking very quickly, is a bit on legacy digitization, and this hopefully will resonate back to what Sean spoke about earlier on. I think we've seen the same thing in the same conversations as what Sean has spoken about. You know, people not sure how to get into the Industry 4 world. Realistically looking at it and going, they're not going to buy a whole lot of new machines. They've got machines that work perfectly well, but just don't produce data. How do they bring those into the Industry 4 world? And I think this will also link into some of the Ioetec conversation that's going to happen afterwards as well. But about 2 years ago, a little over 2 years ago, actually, we started this project, which was just looking at, right, can we advise people around Industry 4 a smaller cost point, an entry level into Industry 4 that resonates with SMEs. So we got a 1980s Bridgeport milling machine that you see there on the left. We got a 1960s Colchester Bantam lathe that you can see in the bottom right, and we chucked some sensors on it. So we've got current sensors, we've got accelerometers, we've got proximity sensors, and a few other bits and pieces as well. But on the lathe, we spend about £400 on the hardware that connects to. So hobbyist kit, Raspberry Pi and Arduino. And on the milling machine, we spend about £4,000 on some National Instruments kit and read the samples in at about 5,000 samples a second, as opposed to the lathe that's about 50 samples a second. And we ended up with two dashboards that were very similar from both devices that you can see kind of there in the top right. And we just started to see, you know, what's possible, what can you do, what's useful, what do people care about. And speaking to people, honestly, the vast majority of what we put on there, people don't care about. And no one in their right mind is going to put £4,000 worth of kit onto a device or a machine that's worth the amount of money that one of these is. It's just not financially, but it doesn't make any sense really. So what we did see is that people saying huge value in being able to see things like, how much does it cost me to use that machine? How much am I utilizing the machine? Could I take on more work? And really, am I using it as I thought I was? And all of those pieces of information, to be honest, most of them can be got just by one singular sensor, plus writing a bit of software, having a bit of software that goes with it. And that really sparked a hell of a lot of conversations for us. And we spoke to an awful lot of companies who have, you know, wanted to do similar. And we've ended up talking to an awful lot of tech providers who have now started to develop products that fit in this area. Because to be honest, I'm not going to tell anyone to use a Raspberry Pi and an Arduino and do what we've done on that lathe anymore, because we're not going to support it. If you call me at 2 in the morning, I'm not going to pick up the phone and help you out. That's not what we're set up to do. And that technology itself isn't the right technology for it. It's not robust enough. It's not IP rated to the levels that are needed, etc. But we've worked with a lot of companies and we've seen an awful lot of tech that's been developed that now does fit that remit. And there's an awful lot of stuff that we can signpost people towards now that really does fit this bill of trying to take data from machines and present it to the stakeholders in the right way, in the right format. And we're continuing those conversations, and some of the bits that we're doing at the moment is we're expanding out the amount of solutions that we have on these two devices to incorporate the solutions provided by some of the vendors out there now. So we worked with people like Austin Consultants, we worked with people like Colchester Group themselves, we've worked with people like Ioetec, but I think a good few of them are on this session. But we're now hopefully in a situation where we can, you know, if you come and take a look around the AMRC, which you're more than welcome to do when we're off lockdown, you can start seeing those solutions. And similarly, the very first example I showed you, be able to see what's the right solution for your for your use case. So I'm pretty sure I've ran over by about a minute accidentally, but hopefully that gives you a bit of an idea. And yeah, if there's any questions, feel free.
That's great. Thanks ever so much. Gavin probably has the best office in the world. There's so many toys there to play with at the AMRC, and if anybody gets an opportunity to go out there, take every opportunity going out. It's a fascinating place. Just a quick question, if I can. I'm trying to keep within the time constraints, Gavin, if you don't mind. One of the questions that's come up is, you know, the smart projector that you had that showed up against the wall, really clever idea, but how does it know which wall it's looking at?
Yeah, so the initial piece that needs to be done there is you do have an initial setup where basically you reference the 3 points usually, so top corner, top left, top right, bottom left, and it understands and then can recognize that initial setup or that datum, I suppose is the right way of describing it. And then it can, if you nudge those around, it's not as good on that particular system, but some of the other systems that do this dynamic projection, if you nudge them around and move them around, they then reference that outline and can self-calibrate themselves again.
Okay, brilliant idea. The other idea I loved was the smart picking thing. If we can tie you up with the smart picking up with Screwfix, it's going to save an awful lot of time in queuing up. Gavin, thanks ever so much. If you wouldn't mind answering any questions that come up on the chat, that would be fantastic. I appreciate your your presentation today. Thank you.
No worries at all. And if anyone wants to get in touch afterwards, they're more than welcome.
Great, thanks very much. We're just going to do a quick poll again as we're switching over to the next presenter, who's going to be Mike Fultz from Ioetec. So just a quick poll, if we might, just to find out where you're from. We're extending our reach, hopefully from the Sheffield area, but I'm hoping that we'll find somebody from the world this time round. But certainly we're spreading our reach out into the UK, which is great, and touching and reaching out to people that we've never managed to get before in our physical meetup in Sheffield. So that's great. Okay, obviously Sheffield, we've got a little bit of network going on there. It's going to show it. So that's brilliant. And there's no proud Yorkshireman there for some reason. Okay, if we can go straight into Mike Fultz then, who's the CTO, my co-founder at Ioetec, to give a bit of an insight about IoT adoption and some of the things that you should be thinking about. Mike.
Good evening, everybody. I hope you can hear me. Let me get my slides up. Sorry about this. The technology seems to be baffling me at the moment. Could somebody share my slides for me? Okay. Can everybody hear me?
Yeah. Good, Mike. Go ahead.
That's great. Thanks. So good evening, everybody. I'm Mike Fultz. I'm the CTO at Ioetec, and I'm going to talk about the proof of concept project that we did to secure legacy IoT at the AMRC. But before I start, just a quick apology. Obviously, I am working from home. I do have company downstairs, and so if anything dramatic happens, like a bird flies past the house, then there may be some noise. So I do apologise in advance. We've already heard from Gavin about some of the IoT projects at the AMRC, but our proof of concept project was specifically to secure legacy equipment. And as the demonstrator, we chose the 1956 Colchester lathe. As Gavin said, there was already a range of sensors attached, but there were concerns about the so-called elephant in the room, which is the data security, or rather the lack of it. But before I describe what we implemented, I just want to run through some of the component parts of industrial IoT. As we have a mixed audience today, some of you may not be familiar with some of the technology. And as all technology people, we do like our jargon, and we can often be quite confusing and difficult to know what it is that you need. So there are 5 distinct parts to an IoT system. First, we've got the sensors, which collect the data. This is then passed to a local hub, which collects the data and either processes it locally or sends it onto the cloud. Once we have the data, we normally require some processing or interpretation, and this is likely to use machine learning or artificial intelligence. And then finally, we need to display the information to a user or pass it on to a user system. So looking at each of these parts, the sensors can collect a wide variety of data, simple things like current, voltage, temperature, and movement, but also more complex data like proximity, vibration, and rotational speed. And there's obviously environmental information as well, like our air quality and gas detection. It really just depends on your requirements and what it is you need to know to enable you to make your business decisions. And I think one of the things, picking up again on what Gavin said, is that there is a tendency to collect too much information. Selecting the information you need and what it is that you need it for is obviously quite an important part of IoT implementation. So once we've got the data collected, it's normally passed on to a local hub, often referred to as the edge node device. These are small computer devices which collate and interpret the data before passing it on to the cloud. And again, there are a lot of alternative connection technologies, simple things like Wi-Fi and Bluetooth, as well as more complex industrial connectivity. But the edge node will normally handle these automatically. But this is an area to watch out for, particularly when you're building your own IoT network. The sensors are not always compatible, and it can be quite difficult to get them to exchange information. For example, a British Gas Home Hive central heating control will not necessarily connect and communicate with a Honeywell radiator control valve, so zonal heating control can be a real challenge. Many IoT systems have some form of cloud capabilities, and there's always a lot of hype about the cloud, but really there's nothing that complicated about it. It's just a lot of computers sitting in a warehouse. What's important is that it provides you with effectively unlimited computing power to process the data, and it distributes data to the users who need access, whether they are based locally or remotely. The available computing power can then be used to extract meaning from the data we have collected. Blockchain could be used for audit and traceability. Machine learning can interpret the data. Big data can be used over a period of time to look at trends. Augmented reality is particularly useful for addressing safety issues, and digital twins can be used to operate or monitor equipment at a remote location. And finally, we have the user display panels to display the data. This may be a standalone dashboard, or it might be an integration into your existing systems. So now you can see how these component parts all link together, from the sensors connecting to the data processing and the communication to the user's screen. So back to our AMRC proof of concept. Our aim was to complement the existing demonstrators and specifically show how IoT can be implemented security. So why is security important? Well, it's a key part of what we wanted to show. And if the purpose of IoT is to collect data and then analyze that data to make business decisions, then the data has to be trusted if it's going to be useful. Security is not just about encryption to make the data confidential. It also ensures that the data is authentic, meaning that we know where it comes from, and integral, which means that it's not being tampered with. These three components, confidentiality, integrity, and authenticity, is what allows us to trust the data. So we installed 3 sensors on the equipment to measure motor temperature, light, and vibration. These were connected via Wi-Fi to a local hub, which then processed the information and sent it to a dashboard. In this instance, we used Node Red, which is an open source dashboard system developed by IBM. The dashboard shows current settings and recent history, and shows an alert if the readings are out of the expected range. To ensure security, each sensor was secured so that it was fully authenticated and the data was encrypted from end to end. That's from the point of collection to the point of delivery. When we designed the Ioetec system, we addressed some specific challenges. First, we needed to keep the cost down if this sort of equipment was going to be used as a practical solution with small companies. And that meant developing software geared specifically to resource-constrained devices. Secondly, traditional security solutions do not work well in this environment. Solutions such as TLS and blockchain are fine for computers and mobile phones, but they don't work well on small sensors. And thirdly, networking can be tricky in some environments, and there has to be a separation of operational technology from traditional information technology networks. One of the issues we addressed in the proof of concept was that the IT department were not that keen on us connecting edge processing hubs into their networks, Not surprising, as we were also asking for extra permissions for data access. It was important that we designed the system to meet their requirements, or we could not have used the equipment. We also need to have a look at the up-and-coming legislation for IoT. Obviously, some existing legislation is relevant, such as NIS, ISO 27001 and ISO 9001. But governments around the world are now looking at specific legislation for IoT, such as the recent laws in California and the planned Secure by Design legislation by the UK government. These will affect how systems can be implemented, particularly with regard to updates, patching, and general cybersecurity. So now we've demonstrated the basic concepts for secure legacy IoT, and we're planning our next steps. There are three particular areas we're looking at. Firstly, extending the range of sensors that have secure connectivity. This applies both to existing sensors and new designs. Secondly, integrating to other industrialized IoT systems, with Siemens MindSphere being an obvious example. And thirdly, looking at integration with machine learning and artificial intelligence systems to extract more detailed meaning from the data that we're collecting. IoT for Industry 4.0 is set to transform manufacturing over the coming years, and although there may still be challenges in implementation, we're getting there, so now is the time to get involved. The market is expanding rapidly, and has been seen over when it comes to agile working and adapting factories to current market need. Thank you for your time. Are there any questions?
Yeah, hi Mike. Yeah, you get enough questions from me ordinarily, so I'll pick up a couple that have come in and try and keep them brief. From Yazan, we've got, why is it important to use IoT, specifically looking at the lathe machine? How did it benefit the business?
Okay, so the principal thing that we were looking for that was usage information. So we could monitor how often it was used and when it was used by monitoring power consumption. And we could also get some guidance on whether the machine was running efficiently, whether it needed to be maintained, by measuring things like motor temperature. So really for the two areas of preventive maintenance and usage information.
Okay, great, thank you. And then from John Clark, if I can get you to answer this one for as brief as you can, if that's possible. What do you think is the most convincing application of blockchain or similar in the context of IoT?
I'm really quite surprised. I'm sorry, Mark. I'm really quite surprised you've asked me that. Starting me off on at this time of the evening on blockchain could be an interesting challenge. Actually, I do think that there is a really good application for blockchain, and that's for audit. One of the things that we can do with IoT is to track what has happened for things like safety analysis and kind of forensic recreation of what's been going on. And blockchain is the ideal method of giving you a long-term audited information trail.
Okay, great. A comment from Demetrius there said we need the whole meetup for this question, so I think he's probably right on that one. Thanks, Mike. Just trying to keep within time now. We've got Alex Kelly coming on next, but just a quick one more poll, if I may, from Rosie. Thank you, Rosie. What best describes your role? And just give an indication for us as to who's in our audience tonight. Thank you. And as I say, we'll be introducing Alex Kelly, who's the head of IoT at Tinsley Bridge shortly. Okay, that's great. It's quite an even spread, which is good news. We've got quite an even spread of the different roles within our audience today, quite evenly spread as well, which is really encouraging, really, that we're not too heavyweight in one particular area. So that's fantastic. So, Alex, last but not least, and thank you. We've maintained the interest level of everybody. Alex, you need to go out with the fireworks now. So, Alex is going to go through, who's the head of IT at Tinsley Bridge, is going to go through the potential of a Sheffield-based SME manufacturer. Thanks very much, Alex.
All right, brilliant. Can you hear me okay?
Yeah, we can. Thanks very much.
All right, brilliant. Okay. I work for Tinsley Bridge in the IT department. I'm just going to go through what type of company we are so you can understand why we're using IoT and how it might relate to your industry or your company. So we've been around a long time. We're a typical company, like Sean says, of the Sheffield area. So we are a steel company. And we made the first parabolic springs, so 175 years ago. And the slide doesn't want to play this. So this was a part for Network Rail. It's a stretcher bar. And it's just to give you an overview of the type of products we make. So we make automotive components for our suspension company. We've got defence vehicle suspensions. We make the stretcher bar that I've just talked about. We've made parts for Wimbledon roof, the Court 1 roof. We've done nuclear projects. We've got a machining knives company. That's a lot of CNC machines, and we make machine knives for cutting up scrap metal and slideway tools. That's used in the airlines industry. We've got quite a broad range of products we make at Tinsley Bridge. So why now for IoT? Well, for me, I think it's the economics of it. The sensors have come down in price. You can get sensors now that I don't know, 5 or 10 years ago would probably cost 10,000, and now they cost £1. Talking about accelerometers and those type of technologies. We've got the edge devices that Gavin was talking about earlier in the talk, and they've come down in price. They've come along a lot. They're a lot easier to use, and the actual connection between the two is a lot easier now, and they're a lot more documented, and there's a lot more education out there. I'm a particular fan of the wireless technologies that are starting to come out, such as LoRaWAN, which takes away the need to power a device. You can just run it off battery, and it can last up to 10 years. So there's no fixed networking required. And open source software is pretty much made it the entry point to IoT free if you know how to use the IoT software. And this is one of the routes that we've gone down. We've gone through the open source software route. There are commercial softwares such as MySphere, which is a online software, which is a platform. So a lot of people can develop solutions for that. So you send all your data up there, and then you can analyze it and display it. It takes away a lot of the hassle of setting up your own solutions on premise. And ThingWorx, they're a good competitor. So if you look at the Magic Quadrant from Gartner, the ThingWorx solution is probably the best. And there's a lot of cloud service providers that are coming along, such as IBM, Microsoft, Amazon with their AWS, and they're all vying for your data. They're all trying to get you onto their platform. So there's a lot going off at the moment in the IoT space. And there's partnerships as well. So you've got things like ThingWorx and Microsoft working together. I don't really understand why they're working together, because for me they're competitors, but they are working together. I really don't know which company is going to be the winners from this. I think there are going to be winners and there are going to be losers. So we played a safe bet and gone for open source for the moment. So why now for IoT? This is going to be key. So on the left-hand side, what you can see is Tinsley Bridge, and these are our two factories. If you add those two factories together, it's about the same size of IKEA. So IKEA is you know how long it takes to get around IKEA? It's a big place. So if you're a production manager or a maintenance manager and you want to know what's happening on the shop floor, by the time you've walked around the shop floor, what you wanted to do has probably already happened, or you've been stopped on the shop floor, and someone's giving you another 5 or 6 problems. So you never actually get to what is the problem that you should be handling right now. So having an IoT system that can sense what's happening on the shop floor and building a model is going to be key to this. I've worked in a lot of different industries. I've worked for software companies, I've worked for an internet service provider, and I've never seen so many audit checks that companies have. We've got the quality audits for ISO 9001, health and safety audits to make sure that our products are qualified, and that we have to look after our staff to make sure that our health and safety is in place. We've got lots of environmental audits that go on. And cyber, for me in particular, it's cyber essentials. We've got to make sure that all our devices are secure, and with IoT, as Mike's been talking, this is going to be ever more important. So with all those audits that we've got a lot of manual processes that happen where people go out and physically check something, and we decide to do that. How frequent we do that by the economics of it, because you've got to send a human to there, and obviously that takes a cost. If we can hook a sensor up, an inexpensive sensor, and we can get that frequency, those checks, more often. If you get more often, you can spot the problems before they happen. And this leads to single source of truth. So you have lots of problems that happen on the shop floor, and a lot of people have opinions about what those problems are, and they might not have enough data to actually understand what that problem is. So you get a lot of debates of what the problem is, and the winner of that debate might not necessarily be the true problem. So connecting up and the machines to try to understand what's happening on a machine, so you've got the truth and everyone's pulling and pushing in the right directions to solve it, is going to be important. There's a lot of energy being lost if you're not all together trying to solve the same problem. On our factory environment, we've got a lot of heavy machinery. So you can see from the top right, we've got some very big electric components. Those components are going to block the wireless signal. And we've had this before with IoT implementation. We've had an external company come out and they fitted a wireless IoT system, and it just didn't work. And it's one reason why we're deciding to do it ourselves. So fixed networking is the way to go, but it can be expensive. Like I said, we're a large area, so it's very time consuming to actually get the cables in place. And some of the places can be quite awkward to get to. Sometimes you've got to go over cranes, sometimes you've got to go under the machines. So getting the sensors installed, it can take a long time. And we've also got a lot of health and safety that need to be implemented, which I'll go into a bit more detail next. So I'm just going to give you a couple of projects that we're going through at the moment. So this is the paint plant. This is a very complicated, it's probably one of the most complicated pieces of machinery we've got in Tinsley Bridge. It goes through 3 different floors. So there's a lot of chemistry that goes on in there. There's a high voltage, and there's also heat. There's another oven to actually bake the product to make sure that the paint dries. And the products have to go through a number of different sequences. And each one of those sequences has to be very tightly controlled, which is perfect for IoT. This particular IoT project is being funded through pitching, so thanks for that pitching. And it's actually in collaboration with the Sheffield University ACES department, with Boyang as a main contact. And so what we're looking to do here is to observe the equipment. So there's things like the filters need changing very often, so we need to understand why they need to change so often. And at the moment, we don't fully understand the reasons for that. We've also got motors. We have to keep the paint running continuously. If the motors die, then that causes us problems. So we need an alert to be sent out to the maintenance team when that happens. And this has come to a light with the corona issue, because our engineers aren't on site as much. So what we need to do is we need to be aware of the problem as soon as possible, so the paint engineers can come on site and make sure that the motor is switched back on. And what we're hoping the university can help us with is some of the analysis and some of the extra hardware and scaling the systems up that we've built already. So this seems to be a topic of the night. I know Gavin's talked about it, Sean's talked about it, the Rolls-Royce has spoken about it, and energy is such an important thing in manufacturing. We heat up a lot of components, a lot of metal components, and it does take a lot of energy. It costs us a lot of money, but also causes problems in the environment. And I suppose one of my challenges here is that if every company within the local supply chain can save 5% of their energy, it's going to save a lot in terms of cost in the environment and also the impact on the energy grid. So what we started to do about a year ago, 2 years ago, I started to get more granular data for our usage. So half-hour data for gas, electricity, and we also compared, started to compare this to the employee clock-ins and clock-outs. So I spent time cleaning the data, preparing the data, anonymising it, and I got the Sheffield Engineering Leadership Academy, which is students from Sheffield University that are a mixed discipline, and they've helped us analyse some of the data. So I mentored them. I wanted to get involved, but I had to keep my distance and just be a mentor to them. And they've come out with some good insights to how we're using our energy, when we're using it. So I'm looking forward to actually implementing some of the actions from there. So I think every manufacturer should be looking at how they're using energy. One of the things on this is that a lot of manufacturers tend to just pay the bills. I spoke to quite a few. They don't really analyse the information, that the bills are coming in. Where's the energy being used? So it's important. They might go out and try and find cheaper prices, but they don't work out which equipment's using the most. We've done quite a few other things as well with IoT. We've visited the AMRC, was it a year ago, 2 years ago now, and we noticed they were hooking up sensors to their coffee machine. So we asked them if they wanted some real data. So we've hooked up some sensors on our C spindles, and we've been sending that to the AMRC, and they've been doing some analysis, some machine learning, some AI on that to categorize parts. So that's quite interesting. It sort of set us on his way where we need to aim for. But with IoT, it's not just about IoT on its own. It's about integrating the different systems, information systems you've got. So your MRPs or your ERPs, and we've got different ERPs for 3 different companies. We've got the time and payroll system that I've talked about, and comparing that with the energy. Agility, so our assets on site, and how we can analyze that with the IoT as well. And these are some of the books that I've read that helps me understand where we're going with IoT. So the book on the left is a very good book to explain the economics, why people are using machine learning now and AI. It's very simple. It explains it in a very simple to understand method. So I definitely recommend that. It's done by one of the professors at Google. And the rise of robots, all about automation. So it's not just about robots, it's about software as well. And the final one, Fourth Digital Revolution. So this is about not just about IoT, it's about incorporating lots of other things in there. So it's talking about robotics, it's talking about machine learning, it's talking about AI, and it's about summing all those different things together, so it's greater than individual parts. And that's it for the talk today.
That's brilliant. Thank you so much, Alex, for that. And really insightful into the real practicalities of trying to introduce digitalization into traditional areas. As you say, I can't imagine walking around IKEA on my working day. It's a phenomenal feat, and explain the complexity and the challenges that are faced by these guys who are in the manufacturing businesses. We're talking about huge footprints that have got to be covered and stuff like that. Really appreciate it. Just a quick question for you, if I may, Alex, is could you explain what the ROI would be, the return of investment achieved for some of the changes, the switchovers, and the timeframes that would be involved?
So some of the savings that we've had is we had some quality problems on one of our products. So we implemented some temperature sensing, and it saved us a lot of money. It saved us a lot of red face with the customers because we were able to supply the parts first time correctly. There was no wastage. So even just hooking a sensor up, I think this cost probably a couple of £100, and it's still saving now. And we did implemented that 2 years ago. So 2 years, and there's no additional costs at the moment. Like we said, we're using a lot of open source software. So yeah, it's just saving a lot of money now.
Sure, and I think it echoes back to our first presenter, Sean's, is that it is a very cost-conscious environment. Every industry is, but I guess it is about the cost benefit, isn't it? About introducing this technology and whether or not you're actually going to get a benefit from it. So, and I know that you do a phenomenal amount of work at Tinsley Bridge trying to sort of introduce these various processes and technologies in to try and make the whole systems there work more efficiently and smarter. So you're keen for it.
There's so many simple things that manufacturing companies can do that will save them a lot of money.
Yeah.
And it's just getting the word out there to them.
Sure, and hooking in the right people with the right. The people who've got the needs to the people who can actually satisfy and meet those challenges. So that's the biggest challenge for us, I think.
So like the way I see it, a lot of people who are coming from university now, they're the people that need to be educated. So when they go into a company, you have someone who understands this new technology. And then they can talk to the IT suppliers, or maybe they can actually do some of this stuff themselves.
That's brilliant. Yeah, thank you ever so much, Alex. Really appreciate it. Thanks for your time.
Okay, thank you.
Cheers, thank you. Well, thank you to all of our speakers. I hope you enjoyed and gained some insights from their presentations this evening. If you do have any further questions, be happy to direct them to any of our presenters, who I'm sure will get back to you. Just a quick final poll, if I may. It's just going to come up on your screen. We're looking ahead at possibly, we may be doing this again through webinar. So just looking at what would be the best time to suit you for future online meetups if we do it. We weren't quite sure whether this time was the right time to be doing it or not. Now we've got a little bit more time on our hands. So it's beginning to pan out that the evening is looking like a preferable time. So that's good information for us. Thank you for that. So just for our shout out session, if I might, I've got a few requests that have come in. If I just get up on my screen so I can just make sure. So from KTN then, the Innovation Network, we're really brilliantly served in Sheffield and all over the country with KTN. Kevin Hallis there saying that there's an innovation funding call going out, or COVID related calls of technology are coming out now and are expected in the future. There'll be industry 4 related calls expected. And of course, there's the standard ISC and the UCAR II calls, which are open at the moment. You can find those on the websites for Innovate UK. But certainly of interest there is the COVID calls. So within the manufacturing industries for sure. Contact, if you go to the ktn-uk.co.uk, you'll news relating to that piece of information. And you can contact Kevin. He's on LinkedIn, Kevin Hallis, Kevin Hallas, based in Wakefield, and very happy to help, although he's based at home at the moment. Second call out for Tracy. She's at the DMC at Barnsley. That's the Digital Media Centre. And hello, Tracy, and thanks for that. There's some EU-funded projects for the Sheffield City region businesses that have been approved and will be set up by the summer. They'll be offering grants for improving productivity and also tech adoption and innovation, and could be crucial as we hopefully emerge from this current situation. Will help companies looking to adopt tech like IoT, as well as those providing the tech. So more work to do on the processes, but once they've been finalised, DMC will be advising that. So again, just search Digital Media Centre in Barnsley and then they'll come up with that. If anybody needs any support on IoT implementations, tech adoption and guidance to support productive and growth, again, the Sheffield City region are very happy to assist. Mark Karwar there, again, will be the contact point there. Finally, I think if I can just find another one on my desk, our next meetup then is scheduled for the 4th of June, so 2 months from now. It's normally the first Thursday every other month. Our theme is planned to be connected health and medical, a topic we're becoming so very familiar with at the moment. Sounding like Donald Trump, it'll be lovely if we're able to have a physical meetup and enjoy Pitchin's fabulous hospitality. But failing that, the lessons we've learned tonight, and thank you to your responses on the poll, we'll be conducting another webinar. Hopefully we'll not too many technical issues. So mark that in your diaries if you can, 4th of June, and we'll be posting details as soon as we've phoned up the event. Just a reminder, this session has been recorded and will be posted on the Pitchin website, as all of our previous events have been. And you can get that on pitch-in.ac.uk. So that's pitch-in.ac.uk. That will give you a recording of tonight's events as well as our previous events beforehand. So it only actually remains for me to say and to wish you and yours a very safe and healthy time in between now and our next meetup. Thank you very much for attending, and it was great to see all the attendees staying with us for the entire duration. So thank you, and again, keep safe and see you again soon. Thank you.